All right. Assalamualaikum and a very good afternoon. Can everyone hear me? Hello.
Yes, Miss.
Okay, can I? All right. So, if can, today we are going to learn new chapter, which is chapter 12. Okay, chapter 12 is heat conduction and thermal expansion. So, for today, I would like to cover the first part of chapter 12. Screen Miss tak ada ke?
Ada?
Ada kan? Alright, it's okay. Let's proceed. So, the first learning outcome is you need to know how to define heat conduction. Sorry. So, the first learning outcome is define heat conduction. And before we can define heat conduction, we need to know the definition of heat. So heat is the type of energy. Heat ini dia adalah is the type of energy. So the definition of heat is the energy that is transferred. So transferred from a body. So body means object. That at a higher temperature to one at a lower temperature by this three process. It is either conduction, convection, or radiation. So when we are talking about heat, you need to understand it is the type of energy. So type of energy that is transferred from where? From a higher temperature to a lower temperature by these three process. So what is conduction? Okay, make a little note there. Conduction is when objects are in contact. When objects are in contact. Whereas convection is fluid current that carries heat from one place to another place. To another place. Whereas radiation is bodies that emit energy through electromagnetic wave. Through electromagnetic wave. So literally, okay, so this is conduction. So when we are talking about conduction, it is when objects are in contact. Okay, when objects are in contact. Okay. Then when we are talking about convection is the fluid current. As you can see here, it is fluid current that carries heat from one place to another place. And what about radiation? Radiation is the bodies that emit electromagnetic wave. That emit energy through electromagnetic wave. So that is the definition of heat. Heat is the type of energy. So the symbol for heat is Q. Okay, symbol for heat is Q. The energy that is transferred from a body at higher temperature to one at a lower temperature by these three processes, either conduction, convection, or radiation. Okay, what about temperature? Okay, temperature is the fundamental quantity. Okay, fundamental quantity that measures the degree of hotness. So the keyword is degree of hotness. Temperature measure the degree of hotness. Okay, so that's all for the definition of heat and temperature. Now, we already know the definition of heat and temperature, then only we can define heat conduction. Okay, may I proceed? Kids, may I proceed?
Yes.
Yes, all right,
Yes.
okay. So now we are going to look at the definition of heat conduction. So this is under the learning outcome. So heat conduction is a process. Heat conduction is a process. Okay, process whereby heat is transferred through a substance from a region of high temperature to a region of lower temperature, same by conduction, convection or radiation. So when we are talking about heat conduction, we know it is a process. When we are talking about heat, it is a type of energy. But heat conduction is a process of heat is transferred through a substance from a region of higher temperature to lower temperature, from higher temperature to lower temperature. That is heat conduction. That's all. So this is the definition that you must know. All right, so now I'm going to proceed with the second learning outcome. The second learning outcome is solve problems. Solve problems related to rate of heat transfer through a cross-sectional area. Okay, rate of heat transfer. The other name for rate of heat transfer is rate of heat flow. Okay, rate of heat flow. So rate of heat flow, the symbol is dq dt. All right, the symbol is dq dt. So it means heat energy per time. So when there is a word rate, bila ada perkataan rate ni, you dah kena faham dia adalah per time. Okay, so rate of heat flow is a scalar quantity. Scalar quantity. It means dia cuma ada magnitude, there's no direction. And unit is joule per second or watt. Okay, why is the unit boleh guna watt juga? Okay, as we know, dq over dt. So Q is heat energy. Heat energy. So we know if energy over time, kita akan dapat apa? Energy over time kita akan dapat apa? Chapter 5.
Power.
Power, very good. And unit for power is watt. So sebab itu the other unit can be watt as well. So you must remember, as you can see from this diagram, heat conduction. So when we are talking about heat conduction, flow of heat, okay, flow of heat is going to flow from a temperature of higher temperature to lower temperature. So it means here is hotter compared to this part, cooler. So that's why we can make a one conclusion that temperature 1 is greater than temperature 2. Or we can say this is the initial temperature and this is the final temperature. So we can say that the initial temperature is greater than final temperature. And the heat will flow from hotter region to a cooler region. That's how the heat will flow. So, what is the formula for rate of heat flow? It is dq over dt equals to negative Ka dt over ds. So, let's label all the terms. So, we know dq over dt is the rate of heat flow. Or the other name is rate of heat transfer. Okay, next A. A is the cross-sectional area. Cross-sectional area. And K, okay, K is very, very important. K is the thermal conductivity. So what is thermal conductivity? Thermal conductivity is the ability of material to conduct heat. Okay, ability of material to conduct heat. Okay, so what does it mean? So if you have higher thermal conductivity, it means dia adalah conductor. Okay, if you ada lower thermal conductivity, maksudnya dia adalah insulator. And we know conductor maksudnya dia lebih baguslah untuk conduct heat compared to insulator. So remember, higher K, higher thermal conductivity means conductor. If lower thermal conductivity, dia adalah insulator. So what is the unit for thermal conductivity? The unit for thermal conductivity is, we have two units, watt per meter per Kelvin or watt per meter per degree Celsius. So if the Kelvin one is the SI unit. This one is SI unit. Okay. So next one. Let's define dTdS. dTdS. So dTdS is temperature gradient. Temperature gradient. So the other name adalah the ratio of the temperature difference between 2 points to the distance between this point. Okay, what does it mean? Maksudnya adalah dTdx. Maksudnya T2 minus T1 over X or T final minus T initial over X. So as we can see, so heat will flow from hotter region to cooler region. So I assume the hotter region is the initial. So the initial or temperature 1. And then when it already flow to the cooler region, so the final temperature. So it will become another temperature lah. So T2 or final temperature. So this is what it meant by. And what is S? Okay, what is S? X is the length or thickness. Okay, for example, I draw it here. For example, I have a metal cube. Okay, I have a metal cube. And for example, I have a rod. Okay, I have two objects here. So let's say I heat up my metal cube from below and I heat up my rod, the left of the rod lah. So bila heat up, dia punya heat flow akan jadi macam ni. This is the heat flow. Okay, this is the heat flow. So we know ini akan jadi the initial temperature lah T1 and here will become T2. Sama juga, here is T1 and here will become T2. So from here to here, dia punya ini adalah distance dia. For this case, kita panggil X ini length. And for this case, kita panggil X ini adalah thickness. Okay, so you don't get confused. X can be length and X also can be thickness. Depends on the question. Okay, depends on the question. So what is the unit for temperature gradient? Unit for temperature gradient is degree Celsius per meter or Kelvin per meter. Alright, now, do you have any question for the time being? Ada apa-apa soalan yang tak faham nak tanya Miss? Kids?
Aku faham.
Tak ada. Okay, kalau tak ada, okay. Kalau ada, tanya je tau. Okay, now, one more thing. Kalau you tengok dekat sini kan, the temperature, the heat flow. So the heat flow, dia akan flow from the hotter region to cooler region, right?
Tak ada.
Tak ada. Okay, baik. So from hotter region to cooler region. So sebenarnya waktu dia flow tu, nampak tak? Dia ada length dia sendiri. So length ni adalah S. Okay? Okay, lepas itu, cuba tengok, dia ada negative sign kat sini. Okay, kenapa dia ada negative sign? So, dia ada negative sign sebab temperature T become less. Become less as the distance x increases. So maksudnya kan. So if you tengok kan. So as the heat flow, dia punya distance tu akan meningkat. X you akan meningkat. Okay. Your X will increases. So as your X increases, your temperature is decreases. Okay. I repeat. So as you can see, this is the heat flow. Okay. This is the heat flow. Okay, this is the heat flow. So when the heat flow, dia punya temperature akan decreases. Okay, the temperature will decreases. So kenapa temperature dia decreases? Bila semakin X dia increases, semakin dia punya length ni increases, distance dia increases, dia punya temperature will decreases. So that's all. Okay. So do you have any question?
Miss,
Ya?
temperature tu tak penting lah nak tukarkan kepada Kelvin.
Tak perlu pun tak apa. Sebab contohnya kalau awak tambah dia, contohnya kita tahu. Okay, kalau korang nak tukar ke Kelvin Miss tunjuk Contohnya, from degree Celsius nak tukar ke Kelvin, kita akan tambah 273.15 Kelvin. Nanti kan bila awak buat soalan, dia akan dapat balik sama. So tak tukar pun tak apa. Not a big deal. Tapi ni extra knowledge lah kalau korang nak. Okay, Miss proceed boleh ke ada yang tengah salin lagi?
Dah salin.
So Miss proceed Okay. So the rate of heat flow through an object akan depends kepada 4 benda. Rate of heat flow through an object depends on 4 things, which is thermal conductivity K, cross-sectional area, and then thickness of material dx or length of the material dx, and also the temperature difference between the two sides dt. So temperature difference ni, the other way kita boleh tulis dia adalah sebegini. So yang 3 segi tu maksudnya changes tau. So boleh je. And thermal conductivity, you kena tahu bila K increase what happen, K decrease apa. So you must know, if K dia increase, dia good conductor of heat. Kalau K dia turun, dia adalah insulator. So that's all. 4 ini sahaja yang dia akan depends on. Okay, now without wasting time, let's proceed to example 1. So a metal cube has a side of 8 cm. Okay, let's draw a metal cube. Okay, so this is my metal cube and we know side dia adalah 8 cm. So here 8 cm, here 8 cm and here also 8 cm. And then given the thermal conductivity is 250 watt per meter per Kelvin. So this is the K. If two opposite surfaces of the cube have temperature of 90 degree and 10 degree Celsius respectively, okay, for example lah kan. So maksudnya we know 90 degree Celsius ini akan jadi T1 and 10 degree Celsius akan jadi T2. This is become the initial and it will become the final temperature. Why? Because kita tahu T1 is greater than T2. So this is the concept yang korang memang kena faham. T1 will always be greater than T2. So for example, dia cakap two opposite sides. So dekat sini 90 degree Celsius and dekat sini is 10 degree Celsius. So this is how the heat will flow lah. Alright. So respectively. Okay. The first question dia cakap, calculate the temperature gradient. Macam mana? What is the formula for temperature gradient? Anyone? What is the formula for temperature gradient? Cuba tengok balik.
dt over dx.
Alright, very good. Dia adalah dt over dx. So we know dt over dx maksudnya dia adalah T2 minus T1 over x. So T2 kita adalah 10 degree Celsius and T1 kita adalah 90. And x kita berapa? Berapa dia punya length? Ni x dia. Berapa x dia? 8. And then we change it into meter. So you will get your answer negative 1000 Kelvin per meter. Kenapa Miss tinggal jawapan dalam Kelvin per meter? Sebab Kelvin per meter is the SI unit. Okay. Let's say kalau korang nak tukar korang punya temperature pergi degree pergi Kelvin also no problem. Sebab if korang tukar pun you will still get the same answer. So no problem. Up to you guys. Alright, now the next question. Quantity of heat flow. Dia minta kita cari apa ya? Quantity of heat flow. Anyone ada idea tak? Quantity of heat flow. Alright, we know rate of heat flow, rate. Bila ada perkataan rate.
dq over dt.
Okay, dq over dt adalah rate of heat flow. Okay, dia adalah rate of heat flow. Tetapi sekarang dia cuma minta quantity of heat flow. Jadi dia minta apa? Very good. Correct. Dia cuma minta Q. Dia cuma minta heat flow. Dia cuma minta heat energy lah. Heat sahaja. So literally kita nak cari Q. Kita nak cari Q, means akan darab dt ke atas. So negative Ka dt dx darab dengan dt. So Q akan equals to, kita tahu K kita adalah 250 area. Macam mana nak cari area of the cube? Anyone? Okay, nak cari area of the tube, panjang darab dengan lebar. Okay, times 10 to the power of negative 2. Okay, and then dt dx. dt dx kita dah ada. Kita dah tahu temperature gradient kita adalah negative 1000. And time. Time taken dia adalah 10 minutes. You have to convert it into seconds. So tekan calculator, you will get 96123 joule. 960,000 joule. Okay, boleh? So if you guys are done, you can try to do example 2. I give you a few minutes to try example 2. Okay, let's try example 2. So example 2 ni, Smith akan bagi hint So dia cakap an insulated spherical glass bulb. Okay, so you have a spherical glass bulb. Okay, Miss draw bulat. Tapi korang anggap ni spherical ya. Sphere. And then we know the radius is 2.5 pm. And then the thickness dia, X dia adalah 0.4 millimeter. Whose outer surface temperature is 30 degrees Celsius. So outer temperature dia adalah 30 degrees Celsius. And dia akan dissipate 55 watt. Okay, apa maksud 55 watt ni? Anyone? 55 watt of heat. Apa maksud dia? What is this? Guys, help me guys. Okay.
Dia punya K ke Mas?
Watt, okay. Dalam watt apa dia? Kalau watt unit untuk apa?
Power.
Tapi untuk chapter ni dia akan jadi?
Rate of heat flow.
Very good. Thank you so much. Dia akan jadi rate of heat flow. So, and then dia cakap given the thermal conductivity of the glass is 0.84. So, this is the K. Thermal conductivity. Calculate the temperature of the inner surface of the bulb. So dia minta kita calculate T1. Okay, let's say kalau awak ada lampu mentol lah kan. So yang akan panas dulu adalah dekat dalam bulb. Baru dekat luar bulb tu awak rasa panas. Sebab itu initial temperature dia adalah inner surface of the bulb. Barulah outer surface of the bulb akan rasa panas. So therefore kita nak cari T1. Okay, kita nak cari T1. So, Miss bagi korang 2 minit untuk try boleh dapatkan T1. Korang dah ada semua maklumat yang lain. Just korang kena masukkan ke dalam formula rate of heat flow. dt over ds. And remember, Miss cakap dt ini adalah changes in temperature. So maksud changes in temperature dia adalah T2 minus T1. So dalam kes ini dia akan jadi T outer minus T inner. Okay, try buat. Lepas tu Miss akan bincang. Alright, now Miss bincang So literally kita tahu dq over dt adalah 55 watt. Okay, 55 watt. And then K dia dah bagi tahu 0.84. Area dia, okay, macam mana kita nak cari area of sphere? Anyone? Area of sphere apa formula dia? Area
4/3 pi r cube.
4/3 ke? Oh, okay. Kalau Miss pakai ni 4 pi r squared. Okay, 4 pi r squared. 4 pi r squared. Okay, jadi area dia adalah 4 pi darab dengan radius. Radius dia 2.5 cm, Miss tukar kepada meter squared. And then darab dengan changes in temperature, Miss biarkan je macam ni dulu. And X thickness dia Miss tahu 0.4 times 10 to the power of negative 3. So you akan dapat changes in temperature dia negative 3.336 degree Celsius. Tetapi kita nak apa? Kita nak temperature inner. Okay, kita nak inner temperature. Jadi masukkan je 3.36 equals to T2 kita tahu 30 minus dengan inner surface of the bulb punya temperature. So end up you akan dapat 33.336 degree Celsius. So that's all. Okay, boleh? So for example 3 akan jadi homework and example 4 pun akan jadi homework. Miss akan discuss tomorrow waktu lecture dekat DK. InsyaAllah esok Miss I feeling better, a bit better. Tomorrow Miss akan masuk ke office. Okay guys, may I proceed? Kids, may I proceed ke korang tengah ni lagi?
Sudah.
Sudah? Yang lain sudah?
Sudah
Okay.
ni.
Okay, Miss proceed ya. Alright, now kita akan masuk graph. Okay, now we are going to learn graph. Okay, so what graph we are going to learn? We are going to discuss graph of what? Of temperature distance TS. So, temperature against distance punya graph. So, length or distance is the same thing lah. Distance S. For heat conduction through insulated and non-insulated rods. Okay, for insulated and non-insulated rods. Okay, so the first one, kita akan bincang heat conduction through insulated rod. So, bila dia cakap pasal insulated rod, awak kena faham. Dia no heat loss. Okay, dia tak ada kehilangan heat to the surrounding. So, if the rod is completely covered with good insulator, okay, awak nampak benda biru ni, dia adalah insulated. Insulator, maksudnya dia akan di-cover oleh insulator. So, you can highlight this one. So if rod completely covered with good insulator, no heat loss from the side of the rod. So keyword yang paling penting, if awak ada insulated rod, maksudnya no heat loss. Okay, by assuming no heat is lost to the surrounding, therefore maksud dia heat can only flow through the cross-sectional area from higher temperature region to lower temperature region. So kalau awak perasan, awak nampak tak heat tu yang warna merah ni, heat tu akan flow sahaja. Okay, through a cross-sectional area, maksudnya through area of the rod ni lah. So dia akan flow sahaja. And we know, for example, ingat tak? Ni selalu cakap, dia akan flow of heat are from higher temperature. So from higher region, dia ada, hotter region to cooler region. So kita tahu dekat sini dia adalah higher temperature compared to here. Kat sini dia adalah lower temperature. So, bila contoh, kalau dekat sini 60 degree Celsius dan dekat sini maybe 10 degree Celsius. Sebab itu kita tahu as the distance increase, nampak tak? Distance dia akan meningkat tau. So, as the distance increase, the temperature will decrease. So, as you can see here, nampak tak? Temperature dia, distance dia ni akan increase. Okay? And then as the temperature increase, as the distance increase, you punya temperature akan decrease. So for example, dekat sini 60 degree Celsius, dekat sini akan jadi 10 degree Celsius. So itu maksud dia. Okay, you tengok semakin you punya length itu kan meningkat, you punya temperature actually tengah menurun. Sebab apa? Sebab dia akan, heat tu dia akan flow from hotter region to cooler region. Okay. So sebab itu you akan dapat straight line graph ini. Ini pun ada sebab. Okay, let's look. So when the rod is in steady state, okay, masuk steady state tu maksudnya dia dah achieve thermal equilibrium lah. Okay, contohnya dia dah achieve thermal equilibrium. So, bila dia dah achieve thermal equilibrium, the temperature falls at constant rate. Temperature tu akan jatuh at constant rate. So, what does it mean by constant rate? So, masuk constant rate, contohnya, dia from 60 degree Celsius. Okay. Contoh, from 60 degree Celsius, dia akan jatuh 59 degree Celsius. Lepas tu dia akan jatuh 58 degree Celsius, dia akan jatuh 57 degree Celsius and etc. So maksudnya, waktu temperature dia tengah fall, dia fall at constant rate. So therefore, rate of heat flow dia adalah constant along the rod. So rate of heat flow is constant. So dq dt is constant along the rod. And then, bila dia constant along the rod, this causes temperature gradient will be constant along the rod as well. So, kalau awak perasan, ini contohnya misal cari gradient dia lah, Miss buat macam ni. Okay. So, actually, gradient dekat mana-mana point ini temperature gradient ni adalah dTds. So, inilah dTds. Ini yang kita panggil temperature gradient. Okay, so temperature gradient dia pun akan jadi constant. Okay, so dTdx dia adalah constant along the rod as well. Along the rod. So what does it mean? Dia constant along the rod. Sebab gradient still the same at any point. Sebab at any point, gradient still the same. Still the same. So you must remember, bila dia insulated, no heat loss to surrounding. Very, very important. Okay, do you have any question?
No.
No? Okay. Okay, may we proceed? Korang dah habis salin ke belum?
Dah.
Okay, I'll proceed ya. Okay, next one adalah heat conduction through non-insulated rod. Okay, this is very important. Tadi insulated rod maksudnya you punya rod is covered lah. Is covered. Tapi sekarang is not covered. So, dekat sini, the metal is not covered with an insulator. Jadi, heat is lost to the surrounding. Okay, so when it comes to non-insulated rod, dia akan ada heat loss. Okay, there will be heat loss. So, the line of heat flow are divergent. Okay, tadi kalau awak perasan, line of the heat flow constant je kan? Maksudnya dia constant je. Daripada X sampai Y dia constant. But now, all the lines of the heat flow akan jadi divergent. Okay, dia akan diverge lah. So, line of heat flow are divergent and the temperature fall faster near the hotter end. So, maksudnya sekarang near the hotter end, here is the hotter end and here is the colder end. So what happened, dekat sini sahaja temperature tu dah drop very fast. Dia akan drop very fast sebab apa? Sebab ada heat loss to the surrounding. So bila dia dah drop very fast dekat hotter region, maksudnya less heat is transferred to Y. So kurang je lah awak kalau perasan ni satu je. Lebih kurang lah. Jadi, this causes the temperature gradient gradually decreases. So, maksudnya temperature gradient awak pun, dTdx awak pun akan decreases along the rod. So, ini akan membuatkan awak dapat curve graph where the temperature gradient at X is higher. So, at X ni lagi tinggi daripada dekat Y as shown in the figure. So, literally, bahasa pasar dia adalah tak semua heat from X akan sampai ke Y. Sampai ke Y. Kenapa? Due to heat loss to the surrounding. Sebab ada kehilangan heat to the surrounding. Sebab itu bahasa pasar dia. So literally, dia kan kita tahu dekat X ni adalah hotter region. Okay, hotter lah. So, bila dia hotter, dia panas, dia mula-mula elok je. Tapi, dia akan turun secara mendadak. Okay, sekarang dia akan fall faster. Maksud fall faster, contohnya, daripada 60 degree Celsius, dia akan turun terus ke 55 degree Celsius. Lepas tu, dia turun ke 47 degree Celsius. Lepas tu, ke 35 degree Celsius and etc. So, maksudnya dia akan fall faster. Sebab tu waktu dekat hotter region ni dia punya heat tu memang the loss to the surrounding. Okay, sebelum sempat sampai dekat Y lagi dia dah hilang. Tapi sampai je ada heat sampai je dekat Y. Tapi kurang, less heat lah is transferred to Y. So less heat is received by Y. So macam dia cakap temperature gradient gradually decreases. Okay, apa yang dia maksudkan dengan temperature gradient gradually decreases? Okay, contohnya Miss buat point Contoh sini point A, point B dan point C. Okay, for example here A, here B and here C lah for example. So cuba kita tengok gradient dia. Kalau kita lukis gradient dia, okay, nampak tak gradient dia makin mengecil. Okay, the gradient is getting smaller. So kat sini kita tahu dia punya temperature gradient tinggi and dekat sini kita tahu temperature gradient dia smaller. Okay. So, one conclusion yang kita boleh buat, kalau you punya temperature gradient ni tinggi, maksud dia you punya rate of heat flow tu pun tinggi. Okay, kalau you punya temperature gradient ni rendah, maksud dia you punya rate of heat flow ni pun akan rendah. Okay, what about, so apa tahu? Okay, awak cuba tengok cuba tengok balik equation rate of heat flow. Equation rate of heat flow, dq over dt equals to negative ka dt over dx. You punya K and A ni always constant. Always constant. Dia tak ada kaitan. So, yang akan berubah pun sama ada rate of heat flow you dengan ini je lah. Okay. So, sebab itu, you boleh buat one conclusion dia adalah dt over dx at x, dekat x ni dekat sini Ini x awak dan ini y awak tau. At x greater than dt dx, temperature gradient at y. Okay, and then sama juga. Jadi dia akan sama juga. You punya rate of heat flow dekat X greater than heat flow dekat Y. Okay, it will become the same. Okay, boleh? That's all. Maksudnya ini, K dengan A ni akan always constant along the rod. Okay, do you have any question? Boleh faham ke?
Boleh.
Boleh. Okay, kalau boleh kita teruskan ya. So now, so this is the last part lah. Combination of two metals in series. Okay, combination of two metals in series. So for example, you will have two material lah. Contoh material C and material D. Okay, ataupun combination of two materials. Okay, first things first. Maksudnya materials ni dia akan macam cantumkan lah. Dia akan join. Oh, dekat sini nampak tak dia duduk sebelah menyebelah. Dia akan join. So the first thing that you kena faham, mereka akan ada insulated. They will be covered by insulator. So bila dia cover with insulator, no heat loss to surrounding. No heat loss to surrounding. Okay, the most important part before kita start, Miss nak korang highlight ni. So dekat sini dia dah bagi tahu dah. Thermal conductivity for material C is higher than thermal conductivity for material D. So which one can conduct heat better? Material C ke material D? That's my question. Yang mana?
C.
C, very good. So awak kena faham So bila K awak tinggi, able to conduct heat better. Able to conduct heat better. Heat better. Okay, jadi kalau K awak rendah, dia boleh conduct heat tapi dia susah lah. Alright, now for example, Miss punya temperature 1, okay, temperature 1 Miss cakap dia adalah 20 degree Celsius lah. Okay, for example And then dekat temperature 3 ni, Miss akan cakap dia 19 degree Celsius. Kenapa? Kenapa dia sangat singkat? Kenapa kalau awak tengok awak cuba tengok daripada sini, daripada okay lah, contoh kosong ni sampailah ke sini, ke T3 ni, from T1 to T3 ni, dia punya length adalah C tau. Okay, kalau korang tengok kenapa dia punya temperature ni sangat, perbezaan dia sangat sikit. Okay, why the difference is less? Okay, ini disebabkan material C ini dia akan cepat panas. Kenapa dia cepat panas? Sebab K dia tinggi. Okay, K dia tinggi. And then kita tahu kalau temperature difference dia akan jadi T2 minus T1. Okay, for example dalam case ni dia adalah T3 lah. So T3 minus T1. So if T3 minus T1, awak akan tengok dia adalah 19 minus 20. So awak akan dapat dia negative 1 degree Celsius. So awak nampak tak dia punya changes, temperature difference dia adalah rendah. Okay, dia cepat panas sebab K dia tinggi. Dan bila K dia tinggi, maksudnya dia able to conduct heat better. So bila dia able to conduct heat better, dia punya temperature difference adalah berkurangan. Sebab itu you will get a steeper graph. Maksudnya graph awak nampak tak? Graph awak macam ni. So one conclusion you boleh mark, you tengok kalau Miss lukis dia punya temperature gradient, temperature gradient dia adalah small. dt dx dia adalah small. When dia punya K increases. Okay, material D, dia boleh conduct heat tapi dia tak boleh nak conduct heat better macam material C. Jadi temperature dia akan temperature difference dia akan tinggi. For example, Miss buat dekat sini 10 degree Celsius. Okay, for example 10 degree Celsius. Kalau 10 degree Celsius, dia punya temperature difference akan jadi T2 minus T3. Sebab ni T2, ni T3, ni T1 tau. So dia punya temperature difference adalah negative 9 degree Celsius. Okay, so bila awak tengok, awak lukis gradient dia sekarang, dia punya dt dx adalah temperature gradient dia adalah tinggi, big. when dia punya K adalah smaller. Okay, dekat sini satu conclusion korang boleh buat, material C can conduct heat better than material D. Material D due to disebabkan K, thermal conductivity untuk material C is higher than thermal conductivity untuk material D. Okay, mesti habis lagi mesti habis cerita. Jadi, bila dia dah sampai steady state is achieved, rate of heat flow through both material adalah constant, sama sahaja. Maksudnya rate of heat flow untuk material C is the same with rate of heat flow for material D. So, and then the best part, area dia pun sama. So, area for material C will be the same with area for material D. Ni adalah area dia. Jadi, kita sebenarnya tahu from the equation of thermal conductivity. Okay. Kan kita tahu thermal conductivity for material C is higher compared to thermal conductivity for material D. And then contoh daripada rate of heat flow dq/dt equals to negative Ka dt over ds. So if I rearrange the equation dan jadikan K sebagai subjek, for example, dq/dt over A dt over ds. So sekarang Miss just nak compare K Miss dengan dt ds. So actually K is inversely proportional to your temperature gradient. Okay, dia adalah inversely proportional. So 1 over, inversely proportional. So maksudnya 1 over. Okay, K is inversely proportional. So maksudnya if you punya K increase, you punya temperature gradient decrease. Okay, if you punya K decrease, your temperature gradient will increase. Itu sahaja. Sebab itu, sejak kita tahu Kc, thermal conductivity for material K is higher compared to thermal conductivity for material D, kita boleh cakap temperature gradient for material C is lesser compared to temperature gradient for material D. So that's all. Okay, boleh faham tak kenapa bila dia punya temperature gradient, bila K dia tinggi, kenapa dia punya temperature gradient small? Sebab dia adalah inversely proportional. Okay, boleh ke? Hello? Mind blowing ke? Kids, are you guys okay?
Okay.
Do you have any question?
No.
Okay, so if you don't have any question, okay, tomorrow during lecture, Miss akan semak example 3, example 4, and tutorial question, chapter 12, subjective number 1 to 4. Number 1 to 4. Miss dah check dah, dia sekejap je nak buat. So if you have any question, you can text me. And tomorrow I'll see you guys, insyaAllah. Okay, if anyone have any question, may stay. Sebab Miss takut korang confused untuk combination to metal in series. So if tak ada soalan, you may leave the Google Meet. Sebab korang nak pergi the next class kan? Okay everyone, thank you so much. Bye-bye. Assalamualaikum.
Thank you, Miss.
Thank you, Miss.
Okay, welcome.
Thank you, Miss.
Okay.
Thank you, Miss.
Okay, welcome girls.
Thank you, Miss.
Okay,
Thank you, Miss.
welcome. Welcome.